Okay, dear students, so let us see what is there in this question. The photons of a certain frequency incident on the metal surface cause the emission of electrons from the surface. The intensity of light is constant. This is a condition which is very important. And the frequency of photons is increased. What is the effect, if any, on the number of emitted electrons and the energy of emitted electrons? See, this is I would say it's a very difficult question because generally this graph is not discussed in the inbox. Like there are a couple of graphs they do teach, but this graph is not available generally. So what is actually happening here is these are two different phenomena taking place at the same time. Number one, the intensity of the light is constant. This is a very complex statement. So I would be coming to this statement later. But the first thing is the frequency of photon is increased. Now, there's a direct relation between the frequency of photons and the energy of the emitted electrons. What happens is that energy of a photon is given by E is equal to h nu. So more is the frequency, more is the energy of the photon. Now just imagine a photon. Photon is the packet of energy and it is thrown towards the electron. So electron is standing there and the particle is coming. The photon, the packet of energy is coming towards it. So what electron does, it catches the photon, it opens the packet and it absorbs the complete energy. Now, a part of that is work function. It is the minimum energy required to get out of the metal surface that is used to getting out of the metal surface. But what about the left? What about the remaining part of the energy? The remaining part of the energy is given to the electron as kinetic energy of the electron. So more is the remaining part of the energy, more is the kinetic energy. So it means now they are saying that the frequency is increased. So if you are increasing the frequency, more energy is given to the photon. It means electron is now having more leftover energy, which will be converted into kinetic energy for the electron. So I am definitely sure about this thing that energy of the emitted electron is going to be increased. That's the part one of the question. Now, the second thing is intensity of the light. Now, as per the particle nature of the electromagnetic wave is concerned, the intensity is defined as it is equal to energy divided by area and time. So it is defined as energy incident on a surface per unit area per unit time. Now, here's the catch. Earlier, we used to say that light is an electromagnetic wave. And so, for energy, we used to use the formula that we use for waves. But in this chapter, we find that no, electromagnetic waves, that is light, is traveling in the terms of particles, in the terms of photons, in the terms of packets of energy. So we cannot use the previous formula. So for this chapter, we provide you with another formula, and that formula is n into h nu. Now what is h nu? H nu is the energy of one photon and n is the number of photons that are falling on the area. So what is the total energy? It is the product of number of photons and the energy in one photon divided by the area of the surface and time we have given, like for how much time the surface was illuminated. Anyway, so this is the intensity now. So now they are saying intensity is kept constant. Now this is constant. Now what do you mean by this? See, h is a constant already. Area we are not changing. Time we are not changing. It means n and nu. So it means that the product of n and frequency is constant, which means lesser the frequency, more is the number of photon, and more is the frequency, lesser will be the number of photons. Now they are saying that frequency is increased. Now if frequency is increased, number of photons reduces. They are inversely proportional to each other. Now if number of photons are reduces, because one electron will absorb only one photon, so it means number of electrons will also reduce, so number of electron will decrease, hence our answer will be B. So this is Professor Varun.